Hey class, today we are going over quadratic functions and transformations, which is found in section 4-1, part 1 of your book. Our goal is to graph quadratic functions. Okay, up to this point, we have talked about parent linear functions and we've talked about parent absolute value functions, and now we're talking about parent quadratic functions. Okay, so it says the parent quadratic function is f of x equals x squared. Its graph is the parabola shown, so the name of this particular graph that you see is a parabola. And then it goes on to say that the axis of symmetry is x equals 0. The vertex will be at 0, 0. All right, so in example 1, graphing a function of the form f of x equals ax squared, we are asked what is the graph of this particular function. So what I want you to realize is that, well, actually let me fix something. All right, so this is a little better. I've gone ahead and added just what the parent function is, which is y equals x squared. So that's the graph that we see here. And so what we're going to do is we're going to go ahead and include what this 1/2, what this 1/2 does to our graph. So if you can remember, 1/2 actually compresses our graph, okay? So it has not moved it, right? I don't see anything as far as like a y-intercept, okay? Which means it would come after the x squared. And I don't see any parentheses telling me that there would be some type of horizontal translation. So our vertex is still going to be at 0, 0. Okay. Now, to be able to figure out what our other points are, with absolute value, all we did was take 1/2 and go up 1 over 2, up 1 over 2. Well, you cannot do that here. You would actually have to substitute in x values to find what the f of x or the y would be. So we're going to start with 1 because that's our next value here. So the way I would do that is I would say 1/2 times 1 squared. Well, 1 squared is 1, and half of 1 is 1/2. So our next ordered pair would be right about here. Okay, now I'm going to test 2. All right, so that'd be 1/2 times 2 squared. Well, 2 squared is 4, and half of 4 is 2. So that will place my next point here. Let's just do one more, and I'm going to bump it all the way up to 4. So 1/2 times 4 squared. 4 squared is 16. Half of 16 is 8. So that's going to bump me all the way up here. So notice we'll get the exact same values on the other side. So -1 and 1/2, -2 and 2, and then -4 and 8. So our graph will look somewhat like this. Okay, so again, what has it done? It has compressed it, meaning it has pressed our graph or smushed it down towards the x-axis. So again, we're given the parent function. The parent function is already listed. It's already shown. So all we're going to do is graph these three functions. So let's start with the first one, which is f of x equals 2x squared. So again, we don't see anything changing as far as horizontal translation or vertical translation. So our origin is going to be 0. Okay, and then we're just going to test some points. So let's test 1. So 2 times 1 squared. Well, 1 squared is 1, and 1 times 2 is 2. So that's going to place it here. And then if I do 2 times 2 squared, 2 squared is 4, and then 4 times 2 is 8. So 2 and 8 would be about here. And then we do the same thing on the other side. So -1 and 2, and then -2 and 8. Okay, so that'll be a stretched graph. Right, and we know it should have been skinnier or more stretched than the original because of the 2. Okay, so let me erase this work down here, and let's do the blue graph. Okay, the blue one, again, there's no translation left to right, up or down, so we're still going to start at the origin. Okay, and now we're just going to apply what we see. So let's test. And here's the deal. When you have fractions, you want to try to use intervals of their denominator as test points because it makes it easier to deal with. So I'm going to go ahead and choose 3. So -1/3 times 3 squared. 3 squared is 9. And then this is really -1/3 times 9, which is the same thing as saying 9 divided by -3. And 9 divided by -3 is -3. So my point will be at 3 -3, which means it'll be the same over here. Okay, let's try and test 6 if it's not off the graph. I'm not sure if it's going to show up off the graph, so let's see. -1/3 times 6 squared. Yeah, it's going to be off the graph because 6 squared is 36, and 36 divided by -3. Yeah, 36 divided by -3 would be -12. Yep, and we're not going to have -12 on here. So I'm just going to go ahead and create whatever parabola this would have been. Okay, and erase my work. Okay, so again, you can tell that this one has shown reflection. Okay, it's reflected, and it has been compressed, meaning it's wider. And again, we know it's compressed because of that fraction, -1/3. The last one, let's try this purple one. So f of x equals -2x squared. So again, we're going to start at 0, 0, the origin, because there is no horizontal or vertical translation. So I'm going to test 1. So that would be, let me do that again. -2 times 1 squared. 1 squared is 1, and then 1 times -2 is -2. So it's going to be down here. So that would be the same thing for +1, or -1, excuse me. Let's test 2. So that's -2 times 2 squared. Well, 2 squared is 4. And 4 times -2 is -8. It's not going to show up down here for me because I've kind of run out of space. So just know that it would be stretched. In other words, it is the exact opposite of the first one that we did. Okay, so this one has been stretched and reflected across the x-axis. So I've used these vocabulary words, and this is exactly what I'm talking about. So reflection is our first one. That's where it basically flips across a certain axis or a certain line. Okay, stretch means we have made our graph thinner or skinnier. And compression is where we make our graph wider. Okay, and then max and min. Minimum is the lowest point of our graph, and maximum would be the highest point of our graph. So in example 2, it says graph each function. How is each graph how is each group a translation of the graph f of x equals x squared? So again, we already have the regular parent function on our graph. And then all we need to do is graph from there. So we have, for the first one, x squared minus 5. So again, now we do see some type of movement, right? We do see a type of translation. And remember, what does -5 do to our graph? That -5 moves our graph down 5. Okay, so then to get the other points that will help our graph, we just create test points around it. So let's say I test 1. So that'd be 1 squared minus 5. 1 squared is 1, and 1 minus 5 is -4. So my ordered pair would be 1, -4. And so that means -1 and -4 would also go together. Let's test 2. So 2 squared minus 5. 2 squared is 4, and then 4 minus 5 is -1. So that's 2 and -1. And then -2 and -1. Let's test one more just to make it wider. If I have 3 squared minus 5, that's 9 minus 5, which is 4. So that's 3, 4. -3, 4. So our graph will be like that. And sorry that I'm so wobbly, but there you go. All right, let's talk about this purple graph. For the purple graph, again, since I can see that there's some type of shift, we need to go ahead and plot our vertex. Okay, so that x minus 4 has told us that we're going to shift our graph horizontally. And remember, it's opposite of what we think in parentheses. So I know when we see negative, we think left, but it's really right. So we're going to go right 4. So here's our ordered pair there. And then we are going to, again, choose our test points. So let's choose 5 because 5 is right next to 4. So I would say 5 minus 4 squared. Well, 5 minus 4 is 1, and 1 squared is 1. So that's going to be 1 and 1. Again, you're actually going to place your values surrounding your vertex, okay, or your axis of symmetry more specifically. All right, let's test 6. So that's 6 minus 4 squared. 6 minus 4 is 2, and 2 squared is 4. So that's 6, 4. And 2, 4. Let's just do one more. Let's test 7. So 7 minus 4 is 3, and 3 squared is 9. So that's going to be 7, 9, and 1, 9. Oops. And so now this graph will look like this. Okay, so in other words, it has been shifted to the right 4 units and graphed. Let's do our try. So again, our original is already placed here. We just need to go ahead and put our graphs on here. So the x squared plus 3, all right, the plus 3 is going to shift our graph up 3 units. So if I go up 3, now I just need to test the point surrounding it. So I'm going to test 1. So that would be 1 squared plus 3. 1 squared is 1, and 1 plus 3 is 4. So my point is going to be 1, 4, and negative 1, 4. Okay, after that, I'm going to test 2. So 2 squared plus 3, that's 2 squared is 4, and 4 plus 3 is 7. So I'll get 2, 7, and also negative 2, 7. And that should probably be enough for us. And that's our graph, okay? Let's go ahead and do, and again, this was up 3, by the way, up 3. Okay, that plus 1, we should already know, kind of like working backwards, that the plus 1 is opposite of what we think. It is going to be a horizontal translation, but it's opposite of what we think. So even though we think positive is to the right, it's really to the left. And so this is left 1. So it's going to be our vertex is here and negative 1. And then we just need to test the points around us. Let's test 0. So I would have 0 plus 1 squared. That's really 1 squared is 1. So I have 0, 1, and negative 2, 1. Okay, after that, I'm going to test 1. So 1 plus 1 squared, well, 1 plus 1 is 2, and 2 squared is 4. So it's 1, 4, and negative 3, 4. I'm just going to do one more. So 2 plus 1 squared, 2 plus 1 is 3, and 3 squared is 9. So I'm going to go 2, 9, and negative 4, 9, which is up here. And so our graph will look like this. And sorry that it's written all over everything, but it has been shifted to the left 1. All right, I really hope this was a good visual for you guys. If you have any questions, let me know in tutoring.